Okay, so welcome to the Paul Web Development Club. This is the first workshop where we learn about backend web development. So, what are we going to cover? We're going to cover backend API development, specifically REST APIs, basic HTTP requests, what are the other frameworks that are out there, and which ones should I be trying to learn heading into this job market and career.
So for starters, there's a bit of confusion between developers, at least in the early college sort of era, of what is backend versus what is front end. Usually when you get thrown into your CS class, you're just taught, here's how to code in Java, or here's how to code in JavaScript or Python or whatever. And you're not told exactly what you're making or how you would actually apply it to the real world. So when you build a web app, there's usually two parts to it. There's the front end and the back end. The back end will refer to the part that focuses on server-side computation. So it's going to be creating and managing behind the scenes functionality. Your server's going to do most of the heavy computation. It's going to usually contain a lot of your private information. And this is the stuff that if you own a company or something, you're going to host this part on either a cloud service, or if you have on-prem software, you would host it in-house. This is the part where you would want heavy machinery. If you're doing anything that is CPU intensive, you're going to want to run it on your back end because your front end is for your user. So when you hit a website, you're going to be hit straight by the front end. Usually this will be in the form of a JavaScript web app front end, or it could be in React, Angular, whatever you want. And this is the part that the user interacts with. So this is going to have all the buttons. It's going to have, video embeds. It's going to have all that stuff that the user sees and physically interacts with. The stuff on the back end is things only the developer should understand, and most of the computation should be offloaded to the back end. So the way the front end talks to the back end is through a REST API. So REST stands for Representational State Transfer. It's a software architecture that will give guidelines for how to build a web API. And an API stands for an Application Programming Interface. They define how one application can request data or services from another application, and they follow a structured format. So typically, this is going to be in the form of JSON objects. They're going to have a specific structure to them. For example, if you're going to make requests to a certain website, you're going to send from the front end a JSON object, and then the back end will take that JSON object, translate it, and then do whatever it needs to do. So if your front end's in JavaScript, you're not sending JavaScript code over to the back end. You're sending a JSON object. And then the back end is going to take that JSON object, translate it into Java, C, C++, C Sharp, whatever it's using. And then with that code, it will do whatever it needs to do. It will finish what it needs to do. And then when it's time to return the data, it's going to convert it back to a JSON object and send it to the front end. And the front end is going to do the same thing. It'll take the JSON object, it'll parse out whatever is getting sent to it, and it will display it on the user side. And typically, when you're running an API, it'll send over JSON objects or sometimes HTML code. And this is all guided through different endpoints via URLs. Your URL, when you hit a URL, you're going to send a request to it carrying information. The backend API is going to interpret the information you give it, and based on what you gave it, whatever it does, at the end it will send a response back. For example, when you go in your browser and you search youtube.com/watchv equals blah blah blah, what you're going to do is it's going to go through some routing, but eventually it's going to hit YouTube's backend API. And when you send that GET request to YouTube's API with the parameter watch v equals whatever, YouTube's servers will then search their databases for the video specified in the parameter, watch whatever, and based on that, it will then send a response back to the front end that will load the video. The reason we're doing this computation on the back end is because if you were to store every single YouTube video on the front end for YouTube, no one would ever reach that page and it would probably fry all their computers. YouTube has tons of servers in their backend all talking to each other, and by delegating all this heavy computation and searching to the backend, you're able to handle heavy computation while also making the user experience fluid and fast. So the way APIs talk is through HTTP requests. So the front end will make an HTTP request to the back end, the backend will then process that request, and then it will return an HTTP response to the front end. That is the essential loop of how most web applications are built and pretty much all over the internet. There's a variety of HTTP methods that are used as commands to standardize web communication. HTTP requests are typically used to perform CRUD operations. CRUD stands for create, read, update, and delete. The majority of things you're doing on a web app is going to revolve around this. And some examples of HTTP methods that correspond with CRUD operations is get, post, put, delete, patch, and trace. Get is equivalent to read. When you send a get request, you're asking for data that can be read. When you send a post request, you're asking to create something. And when you send a put request, you're asking to replace the data in one area with new data. When you ask to delete, obviously you're going to delete. If you send a patch request, it's going to partially update the existing data of something without actually replacing it. Usually it requires a bit more configuration. And then another example is a trace request, which is more so used for diagnostics to echo back certain data about the request. So when you're communicating via HTTP requests, you're going to get a response. And that response will include any relevant data alongside some form of a status code. And it will tell the client the result of their action. This is very essential if you're building an app that has a separate front end from a separate backend. For example, if you build your backend in Java and it's a Spring Boot app, and your front end is a JavaScript React app, you're going to want to have these codes be specific. So that way that way the backend will tell the front end the proper information, and the developers on the front end can build their website in a way that is able to interpret this data more accurately. So for example, we're going to look at some codes. So codes that start with 2, so a 200 form code, will typically signify a successful transaction. A 200 is your OK code. It's just a generic your request was successful code. But sometimes you might want to be a bit more specific. For example, you could send a 201 back, which will mean that the item was successfully created. Usually if you send a post request, the thing you want to receive back is a 201. A 204 is similar in the sense that it'll tell you the request was a success, but it also means that there's no content being returned to the user. This doesn't necessarily mean it's a bad thing. It just means that the server, even though whatever the user asked for was completed successfully, they have no information they need to get back. Outside of successful transactions, there is a 300 code, and those generally signify redirection. An easy example is a 301 code, which essentially will tell the user that the URL has been permanently moved to a new location. So let's say YouTube changes their URL format, and I try to reach a video using the old URL. YouTube's backend is going to send a 301 telling me that the URL has been moved to this new URL, and then my browser will then redirect me to that new URL to view the video I was originally trying to see. Redirection codes, there's a bit more than just a 301, but a 301 is the most common. And then there's a discretion that should be made between a 400 code and a 500 code from the developer's perspective, as it can be useful in debugging. So a 400 code will signify an error on the client's end. For example, a 400 is your generic bad request, and a 404 is your request not found. These usually signify something is wrong in the client trying to talk to the server. For example, say you send a JSON object to the backend in your request and you have a typo. The server should send back a 400 telling you it's a bad request. Another example not on here is a 403, which will tell the user they are not authenticated to make this request. Another example is the common 404, which means whatever the user was trying to get doesn't exist. All of these 400 codes are errors made on the client end, not the server end. To contrast with this, we have the 500 code. Codes that are 500 or 503 or 50 whatever signify that something is wrong on the server's end. So if the user does something and it gets 500 back, they know it's not their fault, it's the server's fault. 500 is your generic internal server error. Usually you don't want to get too specific because you don't want to reveal anything sensitive. But another common 500 code you may get is a 503, which means the service is unavailable. When you have a 503 error code, it could signify that the server is getting large amounts of traffic, and it can't process your request right now, which isn't the client's fault, it's the server's fault, and they would just want to give more information on it. So when it comes to building web apps, there's a variety of different frameworks. Frameworks are going to sort of standardize how you can build a web app. It'll have different built-in features, and it'll make the process easier so that way you're not writing sockets for a program that is going to have several million users. It essentially prevents you from reinventing the wheel. There's a variety of different frameworks, and we're going to cover a couple of them. So one that a lot of people have probably heard about is Spring Boot. It's the most widely adopted Java web framework since DePaul teaches classes in Java. A lot of people probably heard of it. Spring Boot has a pretty steep learning curve though. You need good knowledge of Java and the Spring framework to take advantage of its benefits. The difference between Spring and Spring Boot is that Spring Boot sort of has these independent features of it. So for example, you would have Spring Boot Web, which is for building your basic web app. There's things like Spring Boot Data, which is used for talking to databases. There's Spring Boot Auth. They sort of break it apart into these mini standardized, slightly pre-configured modules. So because of this, it reduces a lot of complexity and configuration by using a set of sensible defaults. It also supports embedded web servers like Tomcat, Jetty, or Undertow, so you can run your application as a self-contained executable jar file. And it works well with the cloud because it's really good for building microservices-based architectures because, like I said, you could have different Spring Boot apps that do different things. You could have one handling auth completely on its own, one handling database transactions. However you want to organize your web apps infrastructure, Spring Boot will have different methods of going about it. So another common framework that you might have heard of is Django. It's a high-level Python framework, and it follows the batteries included philosophy. And so what this essentially means is that everything that you need to build a web app in Django comes in Django. It's all out of the box. It has built-in ORM, admin functionality, and basic security. It also includes a templating engine for rendering HTML pages. So you can include HTML code with some JavaScript, and it can even inherit things and run filters. This means that Django can build a full stack app with just Django and some HTML code. You won't need to use React with Django, but you still can. But it's not necessary. Django is highly scalable. It's commonly used in large applications and enterprise level projects, but it is not as performant as something like Spring Boot. So on top of Django, there's another common Python framework you might have heard of, and it's called Flask. Technically, it's a micro framework, and that's because it's very lightweight and minimalistic. Focuses on simplicity and flexibility. It has very few dependencies, which means the developer has the freedom to choose and build on their own any libraries or components they need. It has very simple routing built into it, though, so that way you can still handle HTTP requests pretty simply, and it's very flexible because of this. It's good for small and medium applications where you need that control over components that don't need a lot of boilerplate code. But obviously the drawback is because it's so empty that if you wanted to build something large scale, it would take forever because you need to code everything. It's very extendable with plugins and third-party applications because of how lightweight it is. So you can install different libraries to handle databases, auth, validation. It doesn't come with ORM, which is different from Django. This is, again, something you would need to extend with or use a third-party library. But the upside with Flask is because it's so simple, it's very good for prototyping. If you need to make a proof of concept to show someone you can build this kind of web app, if you need to run tests internally and you don't plan on actually serving up an app in production, or if you're trying to get your first coding project and you just want something very simple, Flask is the way to go. It'll get the job done really simply, but it can't be scaled into something much larger without a large amount of work on top of it.
So for this next part, we're going to be talking about a framework that probably everyone who's watching this has already heard of and used. It is Node.js. So Node.js is a JavaScript runtime environment that's built on Chrome's V8 engine, and it uses an event-driven, non-blocking I/O model. It's commonly used for server-side web development, APIs, and real-time apps. Node.js is a single main thread running an event loop, which is constantly checking what needs to be done. It can kind of be thought of as like an orchestrator when there's, let's say, like 1,000 tasks that are assigned. This orchestrator will be checking constantly what needs to be done, and it will be delegating these types of tasks. And so how does this all work? So Node is single-threaded event loop that's continuously checking for tasks, but whenever it sees a task, it has the option to delegate heavy tasks to a worker thread pool. So inherently it's single-threaded, but you are able to make it multi-threaded if you choose to use worker thread pools and promise pools. And it uses an event-driven, non-blocking I/O model to handle multiple requests efficiently. So just very basically, incoming requests delegates it to a worker thread pool. The main thread does not await and continues execution, and the worker threads complete tasks and push callbacks to the callback queue, which then gets sent to JavaScript, and event loop executes callbacks when the stack is empty. And this is kind of just like a very basic code sample of how this all works. So when you use just basic Node.js, you just like read a file, and because it's single threaded inherently, it stops and waits. So it reads the file, waits, then it queries a database, it waits once that's done, then it console outputs done. But if you use it the non-blocking way, and you sort of like use specific packages and use these worker threads, you can start reading and it immediately starts moving querying, and then it done. So it does not stop. It constantly is working and doing something. And so why you should use this for your backend? It's fast, it's scalable, handles many concurrent connections. It also uses JavaScript, which you can use for your front end and back end. Although it's not recommended, you should not be using the same language for your front end and back end. You can. If you really want something that's super simple, you can make it and it's done and it's over with. You can use the same language. It's easy, but it's not recommended. And the biggest thing I would give is its large ecosystem. You know, NPM has over 2 million packages, which is just insane. JavaScript was like made in 1 week in the 90s, and nobody thought it was ever going to reach this height. It's the amount of R&D put into JavaScript is just absolutely insane. No other language or platform has ever gotten this much like contributions to, and so it has such a massive ecosystem that you can really do anything with it, and it's great for real-time applications. And so this is very important to note, as I've talked about Node being multi-threaded. JavaScript is not multi-threaded and it will never be. It runs in a single thread and it can only execute one task at a time. Node can be as multi-threaded as possible. You can run 100 threads on Node. It doesn't change JavaScript. JavaScript will always be single-threaded. The call stack executes tasks sequentially, and unlike Java or Python, JavaScript does not create multiple threads by default. It uses an event loop and it's async programming to handle multiple tasks efficiently. And so this is a big difference that a lot of people who use JavaScript need to understand. Concurrency is not parallelism. JavaScript uses concurrent programming and uses async programming, but that is not parallel and that's not multi-threading. It's still all on one core and it executes tasks sequentially. And so concurrency is when multiple tasks start, run, and complete in overlapping time periods, but not necessarily at the same instant. Parallelism is when multiple tasks execute at the same time on multiple CPU cores. And so, how does this relate to web development? Well, Node.js has built-in modules like FS, HTTP, Path, OS, Crypto. HTTP has built-in HTTP request functions like get, post, delete, and put. And then there's streams and buffers. Node can handle large files efficiently, which is generally what you should be doing. If you are creating a full stack app, you should be serving all of your files on the front end as opposed to the back end. Node can definitely help out with serving files there. Node also has cluster modules, which spawns multiple processes to utilize multi-core CPUs, which makes it very efficient depending on the task that you have in hand. And then common use cases, RESTful APIs and microservices. Most people at DePaul learn Express. That's the main thing that we learn. So it's very, very important to know Express. Node is also used for real-time applications like WebSockets and Socket.io. Serverless functions like AWS Lambda, Vercel, Netlify. This really, really helps you with hosting your own front end and back end. And then streaming services like Netflix and YouTube do use Node. Again, it's not 100% Node, but there are some sections of Netflix and YouTube that do use Node. So it's very important to know Node. And then there are limitations of Node. It's very CPU intensive. Again, if you have a single event loop that delegates all of its tasks to a worker thread pool that use up CPU cores, it really depends on how what you're putting in there. If you're putting in some super heavy computation and you're putting like 1,000 requests, yeah, you're gonna fry your CPU. Like it's gonna be really bad. So you have to be really careful with what you're putting on there. There's also callback hell where you have a bunch of nested callbacks and they can be very hard to manage. And in general, async programming is very hard to maintain because like let's say you get an error, it could be in whatever function. There could be like 1,000 requests finished really fast, and it's really hard to tell when something went wrong. So async programming is just inherently hard to debug, and there's also a lot of security concerns. This is inherent. This is not inherent to Node. This is in every single language and platform and framework. But because Node primarily uses npm, Node Package Manager, there are millions and millions of packages that could have security vulnerabilities. So I mean, almost like every single week I hear about an npm package being corrupt, some sort of memory leak, some sort of like, oh, backdoor being involved. Something always happens. There's always a security concern when you're using Node, so just have to make sure that you're not installing the wrong package. And popular frameworks, most popular one is Express. Everyone uses it. It's part of the Marin stack though. MongoDB, Express, React, and Netlify stack. So really have to make sure that you use Express and that you learn Express. It's very popular. And there's also Nest.js, which is scalable TypeScript framework. If you don't know what TypeScript is, that's okay. It's pretty much JavaScript, but strongly typed. It's still JavaScript, but it's just really strongly typed. And then there's Fastify, which is performance focused and it's very low overhead. That one we might also cover in a bit later topic, but not right now. And then Alex talked about this earlier today, but there's also get, post, put, and delete functions. This is all in Node. You can do all these perfectly in Node. And then how does it handle them? So whenever you're creating an app and you're using Node, you usually run the server, and it's usually on port 8080. You run a server and it listens for requests. And so to use something like Express, you can just set up like a bunch of API routes to like listen to certain files. So like you set up an API route to this URL. When somebody goes on that URL and input information, Express is constantly listening to it. That sends you back information. You can put into a JSON, which gets folded into your backend, stuff like that. Really good for middleware. And then when to use Node, so it's best for real-time apps, microservices, lightweight APIs. It has to be small. It's not ideal for CPU intensive tasks. So like let's say you're doing some sort of like machine learning or you're doing some heavy computation. It's really not recommended because Node will use up a lot of your CPU and it's very CPU intensive. So would not recommend that. And then just going over everything that we talked about, there's a main reason why we did not include a lot of code in here. It's because code is always changing. The architecture of your API is very important. Um, the structure of your website will probably not change that much, honestly, but your code will always change. There will always be some sort of new framework coming out, especially in web development. But these are most likely going to be here to stay. These are going to exist for a long time. I really don't see any of these going away in a long time. So just to go over them real quick, Node is JavaScript, easy to use, but it is CPU intensive. It allows multi-threading if you do it properly. Single main event loop. Spring Boot is Java, compiles once for all platforms thanks to the Java virtual machine. High performance, widely adopted in enterprise development, has a steep learning curve because of that, but it also has lots of spin-offs that make microservice building more streamlined, and it is a full stack framework. Then Flask is, of course, it's not a it's not really a framework, it's a micro framework. It's incredibly basic. making it easiest to learn basic HTTP API creation. It is a micro framework, so it is very lightweight and customizable. And because of how lightweight it is, you will need to build features like ORM and auth on your own. And then Django is Python. It has the batteries included philosophy. It's an all-inclusive framework. It has lots of libraries to allow for things like ORM, authentication, databases out of the box. And because of this, it's more limited in customizability. It prioritizes convention over configuration. And it is a full stack framework, just like Spring Boot is. So that's all for now. I'm going to make sure to stop recording, submit this presentation. Then I'm going to upload this to YouTube, and then we're going to see if people are interested in learning other frameworks.